Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is OCR November 2023, paper 4, higher tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Question 1. The price of a phone increases from £240 to £262.80. Calculate the percentage increase in the price of the phones. Okay, so I like to do my percentages with this triangle, FOM. Stick your thumb on it. It's just a good way of remembering how to do all the various types of percentage question, because they're all very similar, but the methods aren't, so you end up picking the wrong method a lot of the time. This is just kind of a way of thinking about questions that avoids that. So the price of the phone increases from £240 to £262.80. So with this method, you just need to work out which is the final, which is the original, which is the multiplier. So the price of this phone was originally £240, so that's what goes here, 240. And then the final price is this one here, isn't it? Because it's gone up in price. So it was £240, that's the original. It's now £262.20, that's the final price. What we're trying to work out is the multiplier, is what the percentage changes from 240 to 262.80. Okay, so then what we do is we cover up the thing we want to find. In this case, it's the m, and that tells me what to do with the other two things. So the multiplier is equal to the final divided by the original, which is £262.80 over £240, and that comes to, calculator, what is that? 262.8 divided by 240, that comes out to be 1.095. 1.095. Okay, now that's a decimal number. This is a percentage question. So the first thing I'm going to do is going to turn that into percentage. 1.095 as a decimal is the same thing as 109.5%, isn't it? You just multiply through by 100. And so what is the percentage increase? Well, if it started off being 100% and it's now 109.5%, then the increase is 9.5%. Okay? So that's 9.5. Question 2. A prime number is a whole number that has exactly two factors. Question A says, explain why 1 is not a prime number. Well, it comes from the definition, doesn't it? A prime number has exactly two factors. And what are the factors of 1? There's 1. So it doesn't have two factors, so it can't be prime. So 1 only has one factor and not 2. Okay, so it's got one factor and therefore it is not prime. A and B are prime numbers. Write down the 6 factors of a squared b. Okay, well, if you think about factor pairs, normally, if I wanted to write the factor pairs of 12, I'd write 12 at the top and I'd write them down in pairs. So 1 goes with 12, 2 goes with 6, 3 goes with 4. Now if I did the same thing with a squared b, then 1 would go with a squared b, wasn't it? Because 1 times a squared b is a squared b. And then I'd need to find some other factors that I can put on the left which pair up with something on the right. So when I multiply it together, I'm going to get a squared b. Okay? So what I'm going to do is I'm going to take the a out and think, well, a times ab is a squared b. And I could also take the b out. So b times a squared is a squared b. And the other factor I could take out, I guess, is a squared. If I could take a squared out and then times it by b. But that's just, oh, I've already got that one, haven't I? I've got that one from before. So that one isn't going to work. So it's those 6 then, isn't it? So I've got 1 and a squared b, a, b, b, and a squared. Question 3a. The table shows the results for sports club's A team. So I've got the results, which are either a win, draw, and loss, and the number of times that occurred. And I now need to complete and label a pie chart to show these results. Okay, so these are out of 40, but pie charts are out of 360. So when you're drawing the pie chart, the first thing you need to do is work out what the ratio is really between those two numbers. Okay, so the ratio of 40 to 360, both sides divide by 40, don't they? Divide by 40, and that's going to give me 1, 2, 40s into 360. That's going to be 9 times, isn't it? So that means this was the number of results, wasn't it? And this is the angle. So that means for every one result, we're going to be using 9 degrees. So in my table, if I write the angle up here, then what I'm going to have to do is going to have to multiply each one of these by 9 then to find the angle. Okay, so what is 18 times 9? 18 times 9, that comes to 162. 10 times 9 is 90. 12 times 9, that is, well, it's 108, isn't it? And you should notice that they actually all add up to 360 as expected. Okay, so now it's just a matter of drawing those angles on the pie chart. Now one line has already been given, so I'm going to use that as my starting point. I'm going to lay my protractor along that line with the center of the protractor in the center of my circle. And then I'm going to count round to 162 for the first angle. So that comes round to here, I think. So make a mark there, and then I can draw that line in. Okay, so that's going to be my wins. And then draw is 90 degrees. So I'm going to have to then put my protractor back down where I left off and then carry on around then, aren't I? So put in my protractor there. I can then measure an angle of 90 degrees and make a mark. Okay, and then lay my ruler out. I can then join that up. Okay, and then that last line then divides my shape into win, draw, and loss now, doesn't it? So the 90-degree angle was draw, and lose is 108 degrees, which kind of draws itself. Okay, so when you're drawing a pie chart, the most important thing is getting those angles right at the top. So most of the marks will come from this table part up here, working out the 3 angles. And then you'll get a mark or 2 for actually drawing it. Don't forget to label your pie chart at the end. If you don't put the win, draw, and loss in there, then you're going to lose a mark for sure. Part B says, here are the results from the sports clubs B and C team. The C team manager says that the pie chart shows that the C team won more games than the B team. Referring to the pie charts, explain why the C team manager may not be correct. Okay, well, you can see that the C team proportionally won more games, but you don't know how many games the B and the C team played. Okay, so C team won more than a quarter of the games, but if it played fewer games, then that more of a quarter might be less than a quarter of the other one. Okay, so We only know that the C team won proportionally more games, but we don't know how many games the B and C team played. B team could have played many more games. I always write too much for these sort of things. You can probably get away with saying B team might have played more games. I don't know. Okay, but I like to be thorough. Question 4. The graph shows Taylor's journey from home to an airport. During the journey, Taylor stops for petrol. Okay, so we can see this journey coming home. So he starts off going at one speed. He speeds up a little bit. He stops for a bit, and then he goes again. So for how long did Taylor stop for petrol? Well, when he stops, he's not moving anymore, is he? So his distance is going to be unchanged for that period. So the period where he stops is this section here. So reading down to the axes from the ends of those two lines, you can see that he stopped after 20 minutes and then started again 2 little divisions later, which is what? So on this scale, I've got 1, 2, 3, 4, 5 little squares between 20 and 30. That spans 10 units, and I've got 5 divisions, so each division must be 10 divided by 5, must be 2. So that means that number there must be 24, and so he must have been stopped for 4 minutes then, so that is 4 minutes. Taylor drives the same route back home from the airport at an average speed of 45 kilometers per hour. Taylor leaves the airport at 10 in the evening, 2200 hours. Work out the time that Taylor arrives home. Okay, so I'm going to draw another triangle for this one. This time we've got distance, speed, time. Distance, speed, time. So what's D, what's S, what's T for these then? Okay, so I know the average speed. It's here, look. Speed is 45 kilometers an hour, so that's going to go here. 45 kilometers per hour. I know the leaving time. I want to know the arrival time. So it looks like it's the time I'm trying to find here. Do I know the distance? Yeah, I can take the distance from the chart, can't I? Because he's going the same route back. So however far he went in the journey there is the same amount of distance he has to travel on the way back. So what's that then? So just reading across from the top of my chart there, you can see that that reached a height of 4 little divisions up from 40. So that is 48 up there, isn't it? Okay, so he must have traveled 48 kilometers on the way there. So he must have traveled 48 kilometers on the way back. Okay, so I got that from over here, look. Okay, so now I just need to cover up the thing in the triangle that I'm trying to find, which is T, and then write out the formula for that then. So the time is equal to the distance traveled, total distance traveled, divided by average speed. So in that case, in this case here, that's 48 kilometers divided by 45 kilometers per hour. What does that come out to be? So 48 divided by 45, that comes out to be a bit 1 and a bit, doesn't it? It's a fraction. Now I want this as a time. Now there is a feature on your calculator to show this in sexagesimal mode. So if you press the format key, go down to sexagesimal, then that will rewrite it as 1 hour, 4 minutes and 0 seconds. Okay, so that's 1 hour, 4 minutes and 0 seconds. Okay, so what's 1 hour and 4 minutes after 2200 hours? So 2200 plus 1 hour and 4 minutes, That comes to 2304. So he must have arrived home at 2304 then. Okay. Question 5a. Write an expression for weight in grams of an object weighing X kilograms. Well, to go from kilograms to grams, you need to work out, well, you have to multiply it by 1,000, don't you? So if X is the weight in kilograms, then in grams, it's going to be 1,000x. Okay? Write an expression for the area in meters squared of a garden with an area of y centimeters squared. Now, converting from centimeters into meters, you're going to have to this time divide by 100, aren't you? Because 1 meter is 100 centimeters, but this isn't normal centimeters, normal meters, it's meters squared. So 1 meter squared is 1 meter times 1 meter, which is 100 centimeters times 100 centimeters. That's 10,000 centimeters squared, then, isn't it? 100 times 100. So that means if I want to convert y centimeters squared into y meters squared, I'm going to have to divide through by that bigger number. So it's going to be y over 10,000. Okay? Question 6. 2 kilograms of carrots and 5 kilograms of potatoes cost £6.36. 3 kilograms of carrots and 2 kilograms of potatoes cost £5.25. Find the cost of 1 kilogram of carrots and the cost of 1 kilogram of potatoes. You must show your working. Okay, so this is actually just a linear simultaneous equations question. We just have to go and form the equations ourselves though here, isn't it? So the first one, 2 kilograms of carrots and 5 kilograms of potatoes cost £6.36. So writing that algebraically, if I say C is the cost of carrots and P is the cost of potatoes, then what I'm saying is 2C plus 5P is equal to 6.36. Okay? And the second equation was going to be, similarly, it's going to be 3C plus 2P, and that's equal to £5.25. Okay? Now we want to find out one of these things, so we're going to have to eliminate either P or C from our equation. I think I'm going to do P because P comes second. It's just going to be easy to write out. So I'm going to take my original equations 1 and 2, and I'm going to multiply them up so I've got the same number of carrots for each. So if I take this first one and multiply it by 3 and the second one and multiply it by 2, then that's going to give me 3 lots of 2C is 6C, 3 lots of 5P is 15P, 3 lots of £6.36. What's that calculator? 6.36 times 3. That comes out to be 1908. Okay, so that's the first one. Second one, I'm going to multiply everything by 2. So 3C times 2 is 6C, 2P times 2 is 4P, and £5.25. I can cope with that in my head, and that's £10.50. Okay, so then what we're going to do is going to eliminate C by subtracting then, aren't we? So if we subtract those, take the second equation away from the first, then 6C take away 6C is no C, 15P take away 4P, that's 11P, 1908 take away £10.50, that's £8, what is it, 19, oh, don't be a hero, just type it in, £10.50, that comes to be £8.58. Okay, so 11p is £8.58, so p is going to be £8.58 divided by 11, then, isn't it? And that's going to be 78 pence. Okay, so the price of potatoes is 78p a kilo. And then, now I know what p is, I can substitute that back in, can't I? I can substitute p equals 0.78 into one of my previous equations. Let's go for, I might as well go for equation 2. Okay, so then 3C plus 2 lots of 78p, well, 2 lots of 78p is £1.56, and that's equal to £5.25. So then taking £1.56 away from £5.25, £5.25, take away £1.56, that comes to £3.69. And that's 3C, isn't it? So then C, the cost of 1 kilo of carrots, is that divided by 3. and that comes out to be £1 and 23 pence. £1.23. Now, it's always a good idea just to double check this. I used equation 2 to work out C from P. So if I just add both those numbers, sub both those numbers into equation 1, just to double check that it all balances out. So check. So if I do 2 lots of the price we think carrots are, £1.23, plus 5 lots of the price we think potatoes are, 0.78, is that equal to £6.36? I'm just going to double check that on my calculator. 2 times 1.23 plus 5 times 0.78, that does indeed come to £6.36. Okay, so I'm happy with that. Right, so yeah, you know, it only takes a couple of minutes to do these little checks in the exams. It's better to know in the exam whether or not you're right than wait until 3 months later and it comes back with a few marks less than you need. Okay, so just take a few moments to check these things if you can. That's quite a nice check for simultaneous equations. Question 7, find all the possible integer values that satisfy the inequality minus 10 is less than 3x plus 2, which is less than or equal to 8. Now these solve pretty much the same way as equations, except I've got 3 parts rather than just like the left-hand side and the right-hand side I normally have with equations. Okay, but as long as we do the same thing to all 3 parts, it should stay balanced. Okay, so first thing I'm going to do is I'm going to subtract 2 from both sides. Can you see I've got a 2 sitting here? So if I take that away from both sides, I'm going to end up with minus 12 is less than 3x, which is less than or equal to 6. And then the next thing I'm going to do is I'm just going to divide both sides by that 3 then, aren't I, to get rid of the 3 sitting in front of the x. So dividing through by 3, that's going to give me minus 12 divided by 3, that's minus 4. And that's less than x, which is less than or equal to 2. Okay, so imagine a number line which has got minus 4 up to 2. So it can't be equal to 4, but it can be equal to 2. What are the integer values then between those two limits? Okay, so it's 4's out because it can't actually be equal to 4, but we do have some other numbers in between, don't we? We've got minus 3, minus 2, minus 1, 0, 1, and 2. And actually, it can be any of those values then, can't it? It can be any of those lying between minus 3 and 2. So I'm just going to list all those out then. Minus 3, minus 2, minus 1, 0, 1, and 2. Okay. Now, you don't have to draw the inequality picture, but it can help visualize the problem and make sure you don't make a silly mistake on pulling out the values. And it didn't take me very long. Question 8, here is the sketch of 6 graphs labeled A to F. Write the letter of the graph that represents the following relationship. Y is directly proportional to X. Okay, so for direct proportion, you need to have a straight line, and that straight line needs to go through the origin. Okay, so it's definitely not that one. That doesn't go through the origin. That doesn't go through the origin. That one does. Okay, so it's that one there. It is C. And then Y is inversely proportional to X. That's going to look like half the reciprocal curve, isn't it? So if we think about the reciprocal curve, it looks like this. Then because like Y is proportional to 1 over X, when you're looking at inverse proportion, then you kind of get this quadrant of the graph, because you don't often get numbers less than 0 when you're looking at these. Right, so yeah, looks it's which one is that? That's E, isn't it? So it's going to be E. Question 9, here are 2 pieces of work. Each shows a question and an incorrect solution. For each part, describe the error made and write out a correct solution. So part A says, factorize x squared plus x minus 20, and the solution is x plus 4, x minus 4. Okay, so when you're factorizing quadratics, start with this number at the end here, the 20. Think about what factor pairs there are. So 20, 1 and 20, 2 and 10, 4 and 5. So you're looking for a pair that multiply together to give you minus 20, but add up to give you 1. Now, obviously, if you're going to get minus 20, 1 is going to be positive, 1 is going to be negative. So when you add these numbers together, you're actually going to be subtracting them, aren't you? So I think it's going to be this number here. So they are right to pick the 4 and the 5. That's the right pair, because look, they've got a 4 and a 5 here. But they've got the symbols the wrong way around. They've got positive 4 and minus 5, and 4 take away 5 is minus 1. And they've got plus 1 in the middle of this this thing. So they've got the signs the wrong way around. The signs are the wrong way around. The correct solution should be x minus 4, x plus 4, plus 5. Because 5 take away 4 is positive 1. Okay. For B, solve 4x plus 5 equals x plus 2. So what have they done here? So they've taken 5. So they've started off by taking away that x. That's okay. So we're taking x off both sides, aren't we? So when you've got 3x plus 5 is equal to 2. So that's correct. And then what they do next, they are subtracting 5. Oh, they've got written it the wrong way around there, haven't they? So that should be 2 subtract 5, not 5 subtract 2. So that's the error there then. So at this point here, they should have been subtracting 5 and getting 2 minus 5, not 5 minus 2. So the 5 and 2 are wrong way around. And the correct solution should be 4x plus 5 equals x plus 2. Taking away the x, that gives me 3x plus 5 equals 2. Then subtracting the 5, I should get 3x equals 2 minus 5, which is 3x is equal to minus 3. So therefore, x is equal to minus 1. Okay? Question 10. Diagram shows a pentagon ABCDE. Yes, it does. Find the area of the pentagon you must show your work in. Now, I don't know about you. I don't have a formula for working out the area of a pentagon. But I do have a formula for working out the area of a rectangle. And I also have one that works out the area of a trapezium. So that's what I'm going to do here. Or you could break it down into 2 rectangles and a triangle if you'd rather. But I know the area of a trapezium formula. I'm just going to use that. Right, so this is going to be area 1. This is area 2. So what is area 1? Area 1 is a rectangle, so it's length times width. In this case, it's going to be 54 times 48, and that comes to 54 times 48. 2,592. I don't usually bother with units until I get to the end. That's a part answer, isn't it? So I'm not going to bother with units just yet. Next one, my next shape, area 2, that is a trapezium. It has formula half a plus b times h. Essentially what you're doing is you're adding your 2 parallel sides together and dividing by 2. In other words, you are averaging them out. Okay, so there are my 2 parallel sides here. So that's going to go here and here. And I'm going to add them together and divide by 2. I'm going to find the average of those 2 sides. Okay, so that's going to be a half times 54 plus 34. And then the h, the distance between them, that's going to be that distance there then, isn't it? And what's that? No, got a slight problem here. I don't know what that is. So what to do? So having a look up here, look, I am going to make a little triangle now because I realise I need it to work out that distance. Okay, I've been given that slant distance down there. So I know that's 42.5. This is a right angle triangle, and I can work out this part up here. This is the difference between 54 and 34. So this part here, look, is 54 minus 34. That's going to have a height of 20, that triangle. Okay, so then I can then work out this distance here using Pythagoras theorem. So this distance, that's going to be 42.5 squared minus the other side squared, 20 squared, all square rooted then, isn't it? Okay, so 42.5 squared minus 20 squared, what's that? 42.5 squared minus 20 squared. That comes out to be 37.5. Okay, so now I do have the height. So my height then is this one. That's my height, 37.5. I'm going to write it there. 37.5. So now to type that into the calculator. So 0.5 times, open bracket, 54 plus 34, close bracket, times 37.5. Now that comes out to 1,650. That's a satisfyingly whole number. So feeling happy about that. So yeah, and then so that's about area 2. So then my total area is going to be those two things added together, then, isn't it? It's going to be area 1 plus area 2. It's going to be 2592 plus 1650, and that is 2592 plus onto 1650. That is 4242. 4242. Okay, that's my final answer. Question 11. Riley and Sam are conducting surveys. They are both given the same list of 12,463 people from which to select their sample. Riley selects every 56th person. Sam selects every 64th person. They both start counting from the first name in the list. Work out how many people will be selected to be in both surveys. You must show your working. Okay, so if I'm starting from person number 1, then and I'm doing every 56th person, how many times am I going to be able to do that then? What is 12,463 divided by 56? Okay, so if I divide that, 12463 divided by 56, that comes out to be 222.5. Okay, so that's 222 point, well, I'm going to round up to 0.6. Okay, so if I pick the first person and then I pick the 222 times 56th person, that's going to be the last person in my list, because I'm not going to get enough people then to get on to the next one, am I? So I think that rounds down to 222 people. And then for Sam, he's doing the same thing, but he's going through every 64th person. So what does that come to? So 12463 divided by 64. That comes out to be 194.7. Now again, I'm going to have to round that one down, because that 0.7, you're not going to get to anyone in the list before you get to the next 64th person. So you could go beyond the end of the list, haven't you? So it's going to be 222 and 194 selected people. So then adding those together, that's 614,416. However, there's a catch, because every now and then, I guess, Riley and Sam are going to land on the same person, aren't they? Okay, if they land on the same person, they can't both have that same pick because it's the same person. So the other thing we need to do is we need to deal with any person that they both picked, and then kind of make sure we're not double counting them. Okay, so in order to do that, I think what we need to do is find the common multiples then of 56 and 64. Now to do that, they're quite big numbers. I think to find the lowest common multiple, given the fact that the numbers are quite big and close together, I'm probably going to use prime factor decomposition here. That's kind of the easiest way of doing it. So what's 56 as a product of its primes? Tapping that into the calculator. If I just type in 56 and go to format, you can see it can come down here and select prime factors. And it will just write out for me. So 56 is equal to 2 cubed times 7. And doing the same thing with 64, typing that into the calculator, then format and go into prime factors. That is 2 to the power of 6. Okay, so then the LCM of those two numbers is going to include all the bases that appear. So I've got like a 2 appearing and a 7 appearing. So my LCM is going to have a 2 and a 7 in it. And then I'm going to pick the highest power that appears for each one of those. So I've got 2 to the 3 and 2 to the 6. So 2 to the 6 trumps 2 to the 3. So I'm going to write a 2 to the 6 in my LCM. And I've just got a 7, so I'm just going to have that 7. So the LCM then is going to be 2 to the 6 times 7, or 64 times 7. And that comes out to be 448. So that means every 448th person is someone that they both picked. Okay, now how many of those are there in 12,463? Because each one of those we've counted twice in that 416. So then we're going to do 12,463 divided by 448. That comes out to be 12,463 divided by 448. That comes out to be 27.7. So that, you know, again, so I'm going to round down in this case because the 0.7 is going to be off the end of the scale. So that means we've overcounted by 27 people. So I'm going to subtract that 27 people from the total. And then, yeah, that should be the number of people who actually are in the survey. So 416 minus 27 was 389. Now, I almost overlooked that, to be honest. I just thought I was going to work out the two numbers, add them together. But then I looked down there and I was thinking, 5 marks for that, and that looks a bit easy. So then I had another think about it, and that's when I realised, you know, there was more to it. So, yes, have a look at the number of marks, because it does give you an indication of the complexity of the problem and how much work you're likely to do. So if your problem goes very easy, just have another think about it in case you haven't kind of overlooked something. Question 12. In a computer game, the player can either win or lose. A student thinks the ratio of the probability of winning to the probability of losing is 2 to 3. The student plays 2 games. Use the information to complete the tree diagram. Okay, so first off we need to go from ratios to fractions here, don't we? So if it's in a ratio of 2 to 3, that means 2 plus 3 equals 5 shares. So winning is 2 shares out of 5 shares, and losing is 3 shares out of 5 shares, then, isn't it? Okay, so if I'm going to write these down as probabilities, I'm going to use those fractions then, aren't I? So it's going to be 2/5 chance of winning, 3/5 chance of losing. Now, presuming you're equally likely to win, and each time you play it's independent of every other time, we're going to assume that these probabilities are going to be the same. Okay. So my completed probability tree should look like that. Part B says, find the probability that the student wins at least one of the 2 games. So winning at least one is winning 1 game or winning both games. So if I wanted to work out that probability, I've got two options. Either I work out the probability of win-win, I add on the probability of win-lose, I add on the probability of lose-win. Or, alternatively, you can think about it as the opposite thing. Well, winning at least one of the 2 games means not losing, okay, not losing both games. So as long as he isn't doing that, then he's won at least 1 game, isn't he? So you can often then kind of simplify these probabilities of winning at least problems by spinning it around and working out the probability of not losing both games like that. Okay, so what's the probability of loss? That's 3/5 times 3/5. So if I take that away from 1, I should be left with probability of winning then at least 1 game. So 3/5 times 3/5, that is equal to, run out of space over there. So that's the same thing as 1 minus 9/25 then. So 25/25 minus 9/25, that is 16/25. So it's going to be 16 over 25 then. Okay, that's the probability of him winning at least 1 game. Now part C says the student now thinks that the ratio of probability of winning to the probability of losing has changed 2 to 5. Explain the effect this change will have on your answer to part A. Well, so obviously he's worse at this game than we first thought, because we thought he had 2 chances in 5 of winning, but now 2 plus 5 is 7. So now we're talking about 2 chances in 7 of winning and 5 chances in 7 of losing. So his chance of winning has gone down, which means his chance of losing has gone up. So in terms of my calculation, I have made that number going to be bigger and that number going to be bigger, and then so when I multiply them together they're going to be bigger. And so when I do the subtraction, I'll be doing 1 taking a bigger number and that's going to end up giving me a smaller number. Okay, so what effect will it have? It's going to have the effect of reducing his overall probability of winning. Okay, so he is less likely to win at least one game. Question 13. Triangle T and triangle A are drawn on the coordinate grid. Part A says, describe fully the single transformation that maps triangle T onto triangle A. Okay. Now you can see that it's got bigger, so it's going to be an enlargement. Okay, so mark 1 I'm going to get by writing down the word enlargement. But this enlargement it's going to have to be a negative value because it's not only bigger, it's also been inverted. Now, and also this is a 3-mark question, so to get all 3 marks on describing a transformation question like this, you get 1 mark for the identifying the correct type of transformation, in this case enlargement, and then the next 2 marks I'm going to get by mentioning the scale factor and the center. Okay, so I'm going to work out the center first. Now to do that I can use what are called ray lines. Ray lines are lines joining matching corners on the image and the object. So if you have a look at this triangle here, T, it's got a right angle here, so on the enlargement it's going to have to match up with the right angle down here, isn't it? Those two go together. So draw in a straight line between those 2 points, like so. It's my first ray line. Okay, they do you can actually extend them beyond, but I don't really need to here. I think because the center of enlargement is going to be somewhere between the two, I know already. Okay, and then the sharp tip of the triangle on this one is up here, and that goes with the sharp tip of the triangle down here. So these two go together. So drawing a line through those 2 points, second ray line, like so. Now that's normally actually enough to work out where the center is, but I like to use the last one as a kind of check on my other two, make sure I haven't made a mistake. So the other pair of coordinates that go together are those, aren't they? The other tip, the other vertices of my 2 triangles. Okay, and then joining those 2 together, you can see that all 3 lines converge on one spot, and that spot there is going to be the center of our enlargement there. Okay, so what's the coordinates of that point there? That is the coordinates -1, -1. Okay, so carrying on with my description of this enlargement then, I've said it's an enlargement, center -1, -1. So saying where the center is, that's my second mark for this question. Final mark is going to be the scale factor. Now to work that out, you're going to find matching sides on object and image and see how much bigger one is compared to the other. So this side down here, look, is 1, 2, 3 squares, and its matching side along here is 2, 4, 6. So you can see it's twice as long. So the scale factor is going to be 2, but it's also inverted, so actually it's going to be a negative number. It's going to be -2. So scale factor -2. Okay, and that's my final mark. So 1 mark for getting the right type of transformation, 1 for the center, 1 for the scale factor. Okay, and then part B says, describe fully the single transformation that is equivalent to a rotation of 90 degrees clockwise about the center 0, 0, followed by a reflection in the y-axis. Okay, so we could probably do that to one of our triangles and see what happens. So if I take triangle T and I do rotate it 90 degrees about the center clockwise, then this bottom left corner is going to rotate round to here. The top corner is going to go to there, and the 4, 1 is going to go to 1 - 4 down here. So my triangle is going to look like this. Okay, after the first step. So after the first step it goes here. Now you can actually do this with one point, but It's a bit clearer if you do it with a shape. I think it gives you a better idea about what's going on. It takes a little bit longer though. So after the rotation, 90 degrees clockwise, it's going to go there, and then a reflection in the y-axis, and then taking that shape and reflect it in the y-axis. So that point's going to go there, that point's going to go there, that point's going to go there. Then I end up with a shape down here then. So then we need to describe how I'm going to get to T, to this red triangle, in one move. How can I get there rather than going via that purple one? How can I get there in one go? Okay. Now, I don't know if you can see, but if I put like a mirror line along this diagonal here, that would work, wouldn't it? I think this is a reflection in the line y is equal to x. Let's just put that mirror line in there to show you. So putting in the mirror line, like that, look. You see that triangle T is reflected onto that red triangle down there then. So describing that then, so single transformation is going to be a reflection. Now to fully describe a reflection, you need to give the mirror line. So in the line y is equal to minus x, that's the equation of the diagonal going downwards from left to right. Is y equals minus x. It's just one to learn that one. Y equals x is up that way, y equals minus x is down that way. Okay. Question 14. The histogram shows the heights of some plants out of a total of 80 plants. Complete the histogram to show the plants with heights between 0 and 20 centimeters. Okay, so we've got a slight problem here in that we've got a bar missing because the bars that we've got on there don't show all the full range from 0 to 70. So how many of the plants have we accounted for in those 3 bars already? Well, frequency in a histogram is equivalent to their area rather than the height of the bar. So we're going to take the length and the width of each of the rectangles, multiply it together, and then we'll get the frequency of people in that bar. So I've just redrawn my numbers because I noticed they didn't print out very nicely. So let's just work out the areas now then. So this first bar, well, the big fat one at the end has got a width of 30. The difference between 40 and 70 is 30. And it's got a height of 1.2 then, isn't it? So then the area of this bar is going to be 30 times 1.2. And that's going to be 30 times 1.2. It comes to 36. So there are 36 people in this group here. You can probably see that there's like one square, 6 times 6 is 36 little squares in there. So I guess one of these squares is equivalent to one person as well, is another way of thinking about it. Right, and then my next bar, it's not going to help us very much in this one because we've got parts of one here. This one has a height of halfway between 1.4 and 1.6, it's got to be 1.5, and then times that by the bar at the bottom, the gap at the bottom, which is 10. So that's 15 people in that one. And then this one, this last bar here has got a height of 1.7 and a width of 10. So that represents 17 people. So altogether so far we've got 36, 15 and 17. What does that add up to? 6, 11, 18, 4, 5, 6, 68. So it adds up to 68. So what remains then? 18 minus 68 is 12. So remaining, and this is already on the graph, so remaining is 12. So we need to draw 12 people on our graph. Now the width of our bar is 20 and we need to represent 12 people. So frequency density is frequency divided by class width. It's going to be the frequency of 12 divided by our class width of 20. So what's 12 divided by 20? 12 divided by 20. That gives me a frequency density for this bar of 0.6. So our first bar has to have a height of 0.6. So bar is going to look like this. Okay. Question 15. P, Q, T and V are points on the circumference of a circle. TV is a diameter of the circle. Where's TV? Is that marked? No. I'm just gonna add that in, I think, before I forget. So TV is a diameter, so that means it must go through the origin somewhere. I'm just going to mark the origin on, so just remind me that that side is a diameter. M is the point on PQ such that PM equals MQ. M is the point on P. Oh yeah, that's already been marked. Look, because they're talking about it's the midpoint of that, and they've put the two little marks on there to show that those two sides are the same length. So that's all good. I do like to read through this blurb at the beginning because often there's bits of information missed off. And here it was this bit here, wasn't it? The TV is diameter. Okay, so don't just look at the diagram, read the blurb, because there's often extra information in there. Okay, now if you hadn't spotted that was the diameter, you might struggle with this question. Right, so complete the sentences to show that triangle TMP is congruent to triangle TMQ. Well, where is TMP and where is TMQ? TMP is this triangle. Is this triangle congruent to TMQ, which is this one, isn't it? It's this half. Okay, are these two congruent triangles? Okay, well, we've got some rules for congruency. We've got side, 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 angle, angle, and RHS, isn't it? Now, this triangle I can see already has got some right angles in it, so it could be RHS. And we know these two sides already match. We know that that side matches that one. So we've got at least one matching angle and one matching side. So we might even be able to use ASA or SAS depending on the length of the other triangle. And actually, I think we can use SAS because we know that they share this side here. So I think this is going to be an SAS proof, even though it's got a right angle in it. It's not going to be RHS. It's going to be SAS. Just happens to be the angle is 90. Okay. So side P equals side PM equals side MQ. That's given. Angle PMT equals angle. Well, it's going to be QMT. That's the two right angles. Why? Well, it's because that VT is the diameter, isn't it? So VT is a diameter and it bisects chord PQ. Okay, it cuts PQ in half. So it must be that they're at right angles to each other. So PQ and VT are perpendicular. Must be so. Okay, you can probably see it if I put some extra lines in. Then you know this is quite a common construction. There's an OPQ is an isosceles triangle, isn't it? It has two radii, and then that if those are the if those two lines are the same length, then it must be at 90 degrees to the diameter. Okay, so that's why that is. And then side MT is shared in both triangle TMP and triangle TMQ. Okay, so it's shared in both. And then so triangle TMP is congruent to triangle TMQ because of the side angle side rule. Question 16. A biologist assumes that the population P of birds on an island can be predicted using the formula P equals 3,800 times 1.042 to the power of n, where n is the number of years after the start of 2020. Part A says write down the percentage increase per year that is used in the formula. Well, it comes from this bit here, doesn't it? 1.042. So that as a percentage, 1.042 as a percentage. We did something like this a bit earlier with the first question. I think it's 104.2%. Okay, so in terms of the percentage increase, that is a 4.2% increase. Okay. because you always start with 100%. So if you start with 100%, you've now got 104.2%. It's gone up by 4.2%. And then part B says calculate the predicted population at the start of 2024. Okay, so the start of 2024 will be 4 years after the start of 2020. So n is going to be equal to 4 in that case. So then P equals 3,800 times 1.042 to the power of 4. And what's that then? 3,800 times 1.042 raised to the power of 4. I make that 4,479.75. Now I'm going to just round that up because it's a population and I don't like the idea of 0.75 of a bird. So I'm going to round it up to 4,480 birds. 4,480. Part C, part 1 says show that the number of birds is predicted to exceed 7,000 during 2034. Okay, so at the start of 2034, we've got n is equal to 14, and haven't we? Okay, so that's 14 years after the start of 2020. So the end of 2034 is going to be the start of 2035. So n is going to be 15. Okay, so presumably I'm going to work this out, and it's going to be lower than 7,000 and when it's 14, and slightly bigger when it's 15. Let's just find out if that's the case. So if when n is 14, then the population is going to be 3,800 times 1.042 raised to the power of 14, and that comes to, just going to go back and delete my 4 from earlier and type in 14 instead. That comes to, yeah, as predicted, that comes to 6,759.76, which again I'm going to round up because we don't like bits of birds. So 6,760. So that's the end of the start of 2034, and then at the end of 24 it's going to be 3,800 times 1.042 to the 15, and that comes out to be, again, we're just going to go back, delete the 4, put in the 5, and that comes to 7,043 and change, which I'm going to round up to 7,044. Okay, so because it's slightly below and slightly above during 2034, population grew from 6,760 to 7,044, so must have been 7,000 during 2034. Okay. Part 2 says a researcher says that between 2022 and 2030, the percentage increase per year in the population will be 2.8. If the researcher is correct, explain how this new information will affect the answer to part C. Okay. Well, in my first answer, we used a percentage of 4.2%. Okay, so for some, if not all of those years, that will be reduced. Okay, so if we reduce that, then the rate at which this is increasing each year is going to also reduce. So we worked out earlier that we would exceed 7,000 during 2034. So if we reduce the amount it's increasing by, then we're unlikely to reach it by 2034. It might take longer for the population to reach that number. Okay, so I'm going to write something like that. I'm going to say it may take longer to reach 7,000 birds, and this would then happen later than 2034. Okay, It's only a 1 mark question, so they're not expecting us to work out exactly when that will be. You know, we can see that if you reduce the rate at which it increases by, it's going to take longer to increase to the amount we're talking about. Question 17a. A sequence is defined by un plus 1 equals 3 lots of un plus 7 and u1 equals minus 2. Work out the value of u2 and the value of u3. Okay, so we've got the value of u1. It is minus 2. And we're told that un plus 1 is 3 lots of, so the next term is 3 lots of the previous term plus 7. So if I want to work out u2, the next term, it's going to be 3 lots of the previous term, u1, which is minus 2, plus 7. Okay, all I'm doing is I'm taking this value here for u1 and I'm imagining it in here, look, where in this expression here. So I'm going to get 3 lots of minus 2 plus 7. 3 lots of minus 2 is minus 6 plus 7 is 1. Okay, so u2 is 1. And then u3, so I'm going to take my u2 value, I'm going to feed that into my function, and this time I'm going to get the u3 value. So 3 lots of 1 this time plus 7. What's that then? 3 lots of 1 is 3 plus 7 is 10. So u3 is 10. Okay. Part B says, here are the first 4 terms of a quadratic sequence. The sequence has a formula xn equals an squared plus b. Find the value of a and the value of b. Okay, well, the value a is always half the common difference of your two values. So the difference between these numbers is 9, 15, 21. So the differences of their differences are 6 and 6. Okay, so the common second difference is 6. So a, the value here, a, is always half of that. Okay, so a is going to be equal to 3. So now our xn term is 3n squared plus b. Okay, let's just work out what the first few values of 3n squared are going to be. So when n is equal to 1, 3n squared is 3 lots of 1 squared. That is 3. And when n is 2, 3n squared is 3 lots of 2 squared. That's equal to 2 squared is 4 times 3 is 12. And when n is 3, then 3 lots of 3 squared, and that's equal to 27. Okay, so the 3n squared part delivers the 3, 12, and 27 into our sequence. I could go on, but I can already see the pattern. So if you see the numbers I've got compared to 3, 12, and 27, each one of these is 5 less, isn't it? These are all 5 less than 3n squared. So b then must be equal to minus 5. So b is equal to minus 5. Question 18. Solve this quadratic by factorization. Now I haven't got everything on one side yet, so I'm going to move everything over to the left hand side first of all. So subtracting 5x from both sides, I'm going to get 2x squared minus 11x, and then adding 3 to both sides. My minus 24 is going to change into minus 21. So then that is going to be equal to 0. Just moving this over to this side and this over to this side. Change sides, change signs. So yeah, so I'm going to get 2x squared minus 11x minus 21 is equal to 0. Now, to factorize it, I start off looking at this number on the end, the minus 21, and think, well, what factor pairs does 21 have? 21 has factor pairs 1 and 21. Or note 2, note 3, 3 and 7, 4 note, 5 note, 6 note. That's all of them, isn't it? You've just got 2 choices there, 1 and 21 and 3 and 7. Okay? Now, so I'm going to have 2 brackets that this factorizes into. Okay? Now, because I've got a 2x at the beginning, I'm going to have a 2x and an x here. So that 2x times x gives me 2x squared. Now, when I need to pick a pair of numbers, either 1 and 21 and 3 and 7, I'm going to put in these brackets, and I'm going to try and get minus 11 in the middle. Okay? Sometimes it's a matter of trial and improvement. You know, you try a pair until you get one that works. So, for instance, if I put the 1 and 21 in here, that's not going to work, is it? Because I'm going to get two lots of 21, which is 42, and one lot of x, which is x, and I can't make 11 minus 11 out of that. That's not going to work. Okay, now if I switch them around, so if I put the 21 this side and the 1 on this side, that's also not going to work, because 2 times 1 is 2. Taking that away from 21 is not going to give me 11 there. So that doesn't work either. So I'm going to try the other pair of numbers. I'm going to try 3 and 7. Now if I put the 3 here and the 7 here, then I've got the 2x times 7. That's going to give me 14x. And then the 3 times the x is going to give me 3x. And I can make 11x out of that, can't I? If this was minus, that would give me minus 14x. And so if this is plus, minus 14x plus 3x is going to be minus 11x in the middle then, isn't it? So that works. It's going to be that way around. Okay, so I just, like I say, I just work out what my possible pairs are, and I put them in until I find a pair that actually fits with the middle term. Okay, so I've got 2x plus 3, x minus 7 is equal to 0. I now want to solve this. Now I've factorised it, I can go on to solve it. If you've got two brackets multiplied together to give you 0, that means one of the brackets must be equal to 0. So either 2x plus 3 is equal to 0, or the other bracket is equal to 0. X minus 7 is equal to 0. Okay? Now if x minus 7 is equal to 0, that's easy. That's just x is 7. So that's one solution. The other one, 2x plus 3 is equal to 0. Take the 3 to the other side. I'm going to get 2x is equal to minus 3. And then divide both sides by 2. I'm going to get x equals minus 3 over 2. And that's going to be my second solution then. So minus 3 over 2 adds 7 are my two solutions. Question 19. The diagram shows the positions of three towns, A, B, and C. The bearing of town B from town A is 53 degrees. Is that on the diagram? I don't think so. The bearing of town B from town A. So if I'm at town A, I'm going to town B. The bearing is 53 degrees. So that means the angle clockwise from north is 53 degrees. So that's 53. The bearing of town C from town B is 108. So C from B is this angle here then, isn't it? So that is 108 there. Okay. AB is 35. That is on the diagram. And BC is 61. That is on the diagram. We need to calculate AC. Okay. Now, this is most likely going to be a trigonometry question in non-right angle triangles. So it's a sine rule or the cosine rule question. Is it the sine rule? Is it the cosine rule? Well, the sine rule is about opposite pairs. Now, I want to find this side here, AC. Now, I should have the angle on the other opposite side, or I can work it out. I'm going to work that out in the middle. Okay, so it's, I can work that one out, and I know this one. So if I've got two pairs, I've got that angle which goes with this side. That's a pair. Will I know that angle there? I don't think I can find that angle here just yet. That's not going to work, I don't think. So whilst I have the 53, I'm not sure I can calculate this one from it, because I don't know where C is relative to it. I've only got one of the angles in there that I can find for sure. So I don't think I can use the sine rule. I can, however, use the cosine rule, because cosine rule is about one angle and three sides, and I've got two sides and a third side. So this is going to be a job for the cosine rule. Okay, so it's not sine rule. It's not about opposites. It's about the cosine rule. Two sides finding the third side. Okay, now in order to use the cosine rule, I am going to have to find that angle at B. Okay, now to find that red angle down there at B, I'm going to have to find this one first. And I can use the fact that I've got angles in parallel lines here. So these two here are what we call supplementary angles or co-interior angles, and they add up to 180 degrees. So if the angle down there is 53, then its pair on the other side is going to be 180. Take away 53. This is 180 minus 53, and that's equal to 127. So that angle is 127, and then I've got three angles on a point then, haven't I? So this angle 108, the 127 I found there, and this angle here should add up to 360 degrees. So then this angle here then is going to be 360 minus the other two then, isn't it? The 127 and the 108. Okay, so 127 plus 108 is 235, and 235 take away from 360, that is 125, isn't it? Okay, so I've got two sides and an included angle, and I want the third side. Okay, so I'm going to write down the cosine rule. Now I actually want to find side B here, because that's the one opposite angle B. And I've got, this is side C because it's opposite angle C, and this must be side A because it's opposite angle A. Okay, so stating the cosine rule for B, B squared equals A squared plus C squared minus 2AC cos B. Now, I always remember that it starts and ends with the same letter, and then you get the other two appearing twice, and that's kind of how I remember the cosine rule form. So then we just need to sub into this. So A is 61, so I've got 61 squared plus C, which is 35, so that's 35 squared, minus 2 lots of 61 times 35 times the cosine of the angle, which we worked out to be 125. Okay, so I think I'm just going to type all of that straight into the calculator. I think that's doable. So 61 squared plus 35 squared minus 2 times 61 times 35 times the cosine of 125. Now, according to my calculator, that is 7,395 and change. Okay, remember that's B squared, so then B is going to be the root of that. So finding the root of my answer, root answer, that is a more realistic 86 to the nearest decimal place, so 86.0. Okay, so I make that 86.0 kilometers. You're just using a straight up use of the cosine rule. Question 20, the diagram shows a circle, centre the origin with a tangent to the circle at the point 4, 2. Okay, that's all on the diagram. Write down the equation of the circle. Well, the equation of a circle is always x squared plus y squared equals r squared. Well, one centered on the origin is. So x squared plus y squared equals r squared. So what's r? R is the radius. Now r is root 20 then from this diagram. So r squared is going to be root 20 squared, which is just 20, isn't it? So the equation of this circle is going to be x squared plus y squared equals 20. Okay. Show that the tangent to the circle at the point 4, 2 has gradient minus 2. Okay. Now, in order to work out the gradient of this tangent, we can use a little trick. We can draw a radius running from the origin 0, 0 up to our point. And that we know is at right angles to our line that we want to find, because a radius is always at right angles to the tangent drawing at the point of the contact. So those two things are at right angles to each other. So if I find the gradient of the radius, then I know that the tangent is going to be the negative reciprocal of it because it is perpendicular to it. Okay, so I'm going to do that first. I'm going to find the gradient of the gradient of the radius, basically. So I'm going to find the gradient of the radius, O at the other point. It doesn't have a name. Let's call it P, OP. That's going to be M, and that's equal to y2 minus y1 over x2 minus x1. That's the form of finding gradient. So my 2 points are the origin and the points 4, 2 then. So I'm going to call the origin x1, y1, and the first point x2, y2, and then I can sub those numbers carefully in then. So y2 then is that number there, it's 2. So that's 2 minus y1. What's y1? y1 is this number here, it's 0. Over then x2, which is my second x coordinate, it's that one there, it's 4, minus x1, which is my first x coordinate, that's another 0. Okay, so then the gradient of this radius is going to be 2 over 4 then, which is a half. Now to show that the tangent has a gradient of minus 2, I can say let gradient of tangent be m2, then m1, m2 is minus 1 because they are negative reciprocals of each other, and therefore m2 will be equal to minus 2 as required. Okay, and it says finally find the equation of the tangent of the circle at the point 4, 2. I kind of ran out of space down there. Let me write up here. So equation is going to be of the form y equals mx plus c, where we just found m, it's minus 2, minus 2x plus c. Okay, so we know it's going to be of that form because that's the equation of any straight line, y equals mx plus c. So we just need to find c. In order to find it, we're going to say that it passes through the point 4, 2. Okay, so subbing in 4 for x and 2 for y, that's going to give me 2 is equal to minus 2 lots of 4 plus c. Okay, so if 2 is equal to minus 8 plus c, then c is going to be equal to 10. Okay, so therefore equation of line is y is equal to minus 2x that we already had plus 10, the y-intercept that we just found. Okay, so we got the gradient from here. Look, m2 is minus 2, so that's the m in your y equals mx plus c, and the plus 10 came from there. Look. Okay, so y equals minus 2x plus 10 is the final answer. Question 21, solve x to the minus 1/6 equals 5x to the third divided by x to the power of 3/4, where x is not equal to 0. Okay. So I think what I want to do is I want to get all of the x's on one side. Okay, I'll leave the 5 where it is for now. So cross multiplying this up to the top and cross multiplying this down to the bottom. In other words, timesing both sides by x to the power of 3/4 and dividing both sides by x to the power of 1/3. That is going to give me x to the minus 1/6 that was already there, multiplied by x to the power of 3/4, which is joining us from the denominator of the other side, divided by x to the 1/3. Okay, so the x to the 1/3 ended up on the bottom over here, and the x to the 3/4 ended up on the top, and the x to the minus 6 hasn't gone anywhere, it's just staying where it is. Okay, so then that is going to be equal to 5, because the 5 is also staying where it is, hasn't moved. So the 5 was there, it's still there. Okay, right, so then we just need to resolve those. So when you multiply numbers with the same base, you add the indices, and then when you divide, you subtract the indices. So we're going to be adding minus 1/6 plus 3/4 minus 1/3. Okay, now I could do it all in the picture there, but I might just do it on one side because I know I'm going to be adding these fractions together, adding and subtracting these fractions together. I might just do it at the side here and say that minus 1/6 plus 3/4 minus 1/3. If I just work it out over here, I think that's fine. So what's that then? What's the common denominator of 6, 4 and 3? They all go into 12ths, don't they? So that's equal to minus 1/6 is minus 2 over 12. 3/4, if I times top and bottom by 3, that's going to be 9/12, minus 1/3, which is 4/12. So minus 2/12 plus 9/12 minus 4/12. What's that then? So 9/12 take away 2 is 7/12, take away 4 is 3/12. So that equals 3 over 12, which is the same thing as 1 over 4. So that means that this all resolves down to x to the power of a quarter is equal to 5. Okay? Now I could have done that all as powers, and I could have written x to the power of minus 6 plus 3/4. Just been a bit squashed. So I just decided to do it kind of separately by itself and then reinsert it into my sum over here then. So x to the power of 1/4 is 5. So then if I raise both sides to the power of 4, I'm going to get x equals 5 to the power of 4. What is 5 to the power of 4? 5 times 5 is 25, times 5 is 125, times another 5, what's that? Is that 625? So x equals 625. That's my answer. Question 22. You're given this identity, 2 minus 3 root 18 over root 18 plus 4 is equal to a root 2 plus b. Find the value of a and the value of b. You must show each step of your working. Okay, so you need to be clear and concise about what we're doing here. We're going to start with the left-hand side and make it look like the right-hand side. When these show that questions, you don't want to be moving things over the equal sign. So we're going to start with the left-hand side and make it look like the right-hand side. So the left-hand side is equal to 2 minus 3 root 18 over root 18 plus 4. Okay. Now notice at the bottom here we have got a fairly horrendous irrational denominator. Now to rationalize this, what you need to do is you multiply through by the same thing, top and bottom, root 18 and 4, but rather than having the plus sign in the middle, we switch the sign to a minus sign. We call this the complement. And what happens, you'll see what happens in a minute if you don't know already. So times and top and bottom through by this, that is going to give me, on the top I'm going to get 2 lots of minus 3 root 18 lots of root 18 minus 4, and then on the bottom we're going to get root 18 plus 4 root 18 minus 4. Now I don't know if you recognize what's on the bottom. It's a bit like a difference of two squares, isn't it? Where you've got the same things either side and one's plus one's minus. Now when you multiply these things together, so when I times root 18 by root 18, root 18 times root 18 is just 18, okay, and then root 18 times a minus 4 is minus 4 root 18, okay, and then 4 times root 18 is plus 4 root 18, and minus 4 times 4, this bit here, is minus 16. Okay? Now I don't know if you've noticed, but I've got two identical terms in the middle with different signs. So these two cancel each other out. And that just leaves me with 18 minus 16 on the bottom, and 18 minus 16 is 2. Okay, so we've managed to resolve most of our denominator down to the number 2. Okay? So that's why you multiply through by the complement, because you end up with a whole number at the end of it. Okay. Now normally when I do this, if I'm doing it fast, I wouldn't show the minus 4 root 18 and plus 4 root 18. I'd just be looking at this and know it's going to be root 18 squared, which is 18, minus 4 squared, which is going to be 16. 18 minus 16 is 2. Well, after you've done this a while, there's no real need for writing out this middle step. You can go straight from here to here in one go. Okay, but this is a show that question. They want us to show our work in, so I'm going to put it in. Okay, and then on the top, what we're going to do on the top. So we're going to do FOIL, but on the top this time. So I'm going to have 2 times root 18. That's going to give me 2 root 18. And then I've got 2 times minus 4. 2 times minus 4 over there. Look. That gives me minus 8. And then switching to the second term, I've got minus 3 root 18 times root 18. So root 18 times root 18 is 18, and 18 times 3, what's that, 18, 36, 46, 50, 54. That's going to be minus 54. and then I've got minus 3 root 18 times minus 4. So a minus times a minus is a plus, so it's going to be positive, and 3 root 18 times 4 is 12 root 18. Okay, right, I wrote all that on the wrong line. I'm just going to budge it up to the one above. Okay, sorry about that. Let's just move it up there. I can do that because I'm using a computer. You'd have to cross it out and start again. Right, oh, I missed a bit. Okay, so then collecting like terms, I've got a 2 root 18 and a 12 root 18, and adding those together then, that is going to give me 14 root 18. Okay, and then I've got minus 8 minus 54. Combining those is going to give me minus 62. Now I can factorize 2 out of both of those top terms, so that's going to be 2 lots of 7 root 18 minus 31 over 2. So then those two things cancel, and that just leaves me 7 root 18 minus 31. Okay, so we're down to, that's equal to 7 root 18 minus 31. Okay, so we're almost there. We're almost in the form a root 2 plus b, except I've got a root 18 and not a root 2. But you can see that 18 is 9 times 2, so I could rewrite that as 7 lots of 9 times 2 under the root symbol minus 31. Okay, and so then I can take the 9 out. Root of 9 is 3, and combine it with the 7, so that makes 21 root 2 minus 31. Okay, and now we are in the right form, aren't we? So our a term is 21, and then we've got our root 2, and then we've got the b term, which is minus 31. Okay, so it is the right form. So I can say that's equal to the form of the right hand side now. So a must be 21, and b must be minus 31 then. Okay, and then we're done.
Mr. T, he's the best, helps you ace every test. Maths worries now.